All right, everyone. Well, we apologize for the delay. We've had trouble getting one of our panelists in. So I think what we should do is move forward as best we can, and we'll appreciate your forgiveness and a little bit of hiccups as we start this presentation today. Um, I would like to thank you all for being here. I would like to tell you good morning, attendees, and welcome to the webinar, What is Software Precognition? Today, you're going to hear and see how to have your own crystal ball to enable seeing in advance exactly how your software will perform and behave before release. But don't worry, it's not magic, but it is great innovation in engineering. Our speakers will cover industry challenges today, where this capability fits, and how it helps in assuring defect-free software at the velocity of business that you need to move today. Also, there'll be, assuming we can get our other panelists back on, there'll be a demonstration of the technology, and then there'll be a Q&A. I do encourage you to put your questions in Q&A that we can cover it in. We have plenty of time, and certainly we will make ourselves available with contact information afterwards. So without further ado, I'm going to now turn it over to our first speaker, Mr. Frank Huerta, CEO and co-founder of Curtail.
Thank you, Deborah, and thank you everybody for joining our webinar today. As Deborah said, we want to talk to you about some exciting things that we're doing here at Curtail. We believe we have a disruptive technology that dramatically streamlines and improves the software development lifecycle process. We can see and stop software bugs before release. We can see and stop performance issues before release. We can find and fix these problems before a customer ever sees them. And we have a unique and faster way to RCA, or to root cause analysis. So let me tell you about our team, a little bit about our background. So Deborah, Robert, and Robert will be joining shortly, have all worked together at a company called Recourse Technologies. And I co-founded that company back in 1999. And Robert was like our 5th or 6th employee. Deborah was our lead salesperson. And that company was acquired by Symantec in 2002. We developed some very innovative intrusion detection and intrusion prevention products at Recourse. We're the first company to commercialize honeypots. We also developed network intrusion detection products. At the time, you were only able to find network attacks based on signature matching or pattern matching. So if something came down the line, you would match it to something you knew was already in a database. So you couldn't find new attacks. And at the time, we were able to, with a new technology called protocol anomaly, find new attacks, or what they were termed as zero-day attacks, right? And so why are you mentioning all this to me, Frank? Well, I'm mentioning this because this is very similar to what we're doing today at Curtail and what we're going to talk about today with our product Regrade. We are able to find zero-day bugs, if you will, zero-day vulnerabilities, or things that you haven't tested for, or didn't write a test for, or couldn't or didn't know about. We can find those bugs, and we can also find the bugs that you would normally find as well. And we can do all of that. We can find the unknown bugs, we can find the known bugs, all prior to release without any impact on your customers. So this slide's a bit of a visual shocker, if you will, but it's meant to be. There are all kinds of costly bugs and time-consuming outages that happen because of poor software quality, really. And many of these can lead to security problems. So you see companies here listed. There's Tesla, there's VW, Slack, right? And if you look at the center of the slide here, it's an article on the cost of software quality. It's a $2 trillion problem. It's $2 trillion plus. It's a huge number. So obviously we've been making investments to try and improve this process. We've been trying to do things better, but things are still a real problem out there. And actually this number is growing. This $2 trillion number is growing. And so as we are trying to have our software go faster and do more things and have more revs, we are still, we're still challenged by the problems out there, right? And so we believe a new approach is needed. So this is a slide that Gartner published late last year in December, and it really speaks to the things that we're doing. So as far as application behavior prediction and predictive application failure, root cause analysis, these are all high value things. But if you go over there on the left side, really being able to predict how your application is going to behave and if it's going to fail, these are really high value items that aren't currently served well by the market. They're not very feasible. And so when I saw this, I was like, this is exactly what we do, right? We actually are able to predict how something's going to behave. We're actually going to show you that. And we're actually going to be able to show you if it's going to fail all ahead of time. And we also have unique root cause analysis for that. So the market's message to this is how they are going to solve it, or how Gartner believes the market can solve this problem, is through AI ops, right? And what that means is our understanding is that there's a lot of telemetry and there's a lot of data that you can collect from logs after the fact. There are, you can look at performance data, you can look at traces. All of this stuff is after the fact. And I mean by after the fact is after you release something, and then maybe something goes wrong, right? Or something starts trending wrong, right? But the point is something has already been released and something is now changing that doesn't look good, or it's gone bad already. And so you put together a lot of, you do a lot of analysis, and AI Ops says, hey, let's look at all of this post-release data and let me see if I can make some inferences on it. And maybe I can stop things and roll back quickly, right? I think we lost the slide there, so if we can go back real quick. But the idea is to roll back really quickly, right? And so you want to minimize the MTTR, as it's known in the vernacular, mean time to repair, mean time to recovery, mean time to resolution, right? So that means the mean time or the average time that something has impacted you as a bug or something, or as a negative experience. And the time you roll that back to a prior version, right? You want that to be small because you're saying, oh, my customers won't be impacted maybe for that long. We want to challenge that today, right? We want to say, why do we need a mean time to recovery at all, right? And that's exactly what we're doing. We're aiming to eliminate mean time to repair, or MTTR, if you will. Bugs, as you know, are expensive after you release and find them, right? Customer support usually finds out about them. Customer support's expensive. Triaging bugs after the fact, very expensive. You don't want your developers fixing bad code. You want them coding new features, right? You want them coding new things. But if they're dealing with prior versions, that's not good. Also, you don't necessarily want to write new regression tests for something that shows up after the fact, right? Because now you're taking up QA time to do that, and that's not really helpful, right? So what if you could eliminate all of those things: your customer support, your triaging, your regression tests? What if you could find all of that before you release? And that's what we're really doing here. We are eliminating the MTTR and finding all of these bugs beforehand. And this is how we can streamline and improve the software development lifecycle process. So, what are the typical choices out there to do that today? And I'm going to generalize here. Typically, you have some technologies that you try to do things before you release, right? Obviously, you're going to test, you're going to do maybe some code scannings, vulnerability analysis, scanning, and you're going to write tests. And that's really good. But the problem is a lot of these tests are one-to-one. So you scan for one thing and it will hopefully look for one thing. And this is a generalization, but in general, you write a test for one to find one type of bug, and then you find that type of bug. But you're not going to be able to find the unknown bugs or those quote 0-day issues, those 0-day bugs that can really trip you up after release. Then after release, we've already described on the previous slide, there's a lot of other things that you look at, right? You look at logs, you look at performance metrics. But again, these things are all after the fact. So you're going to look at it and say, gee, my server's down, or gee, that was a bad thing. My performance is bad. Again, these are things already things that have happened after the fact, and you have probably already experienced a negative customer problem, right? And then, as we described also on the previous slide, you have after the fact log. I mean, you can apply AI to these problems to sort of deal with these issues after the fact and try and reduce that MTTR. And again, we are about, really eliminating that in the future if you can, and being able to see things ahead of time and saying we don't need MTTR. And we do this by a technique that we developed, which is called real-time network message comparison intelligence. So we've patented technology to be able to look at a new version of software that you want to introduce, compare it to an existing working version of software, and that allows you to find the differences. And in doing so, we actually allow you to cover more testing with less effort by, in a way, really passively crowdsourcing your users' behavior and how they already interact with the app. And that allows you not to have to write additional tests or scrape through after the fact logs. And so this is how we do what we call, this is, digital precognition. This is how we find things beforehand. And so the term precognition, many of you may have seen the movie Minority Report with Tom Cruise, or read the Philip K. Dick novel associated with that. The precogs in that movie were, they had a capability to see into the future and to look for crimes and see the crimes before they were committed. It's sort of a crystal ball fashion. They could see something that was going to happen, and then the police would go stop the crime from happening. In a similar way, we are being able to see these bugs happen, but without any impact to your customers. So we will run the same traffic at the new version and see how those users would interact with it, but it's separate. And we can find the differences between the current version and the new version and see any changes. And that's how we can predict and show if anything's going to go wrong. And this is how we really address application behavior and failure prediction that we talked about on the prior page. So that's kind of the background on what we do. I'm going to let Robert tell you, since he's now joined, I'm going to let him tell you about how this technology actually works, and then show you a demo later.
So really the way that we do this fundamentally is by comparing the network behavior of two different software packages that are supposed to be providing the same service. And so at the most basic level, every network service is basically a software package that has its inputs and its outputs as network traffic. And that's really the behavior of the software, is what those inputs and outputs, or what the outputs are in response to those inputs. And so anytime you change the software, and that causes something that changes the user's experience using that network service, that ultimately manifests as a difference in the network messages and in the behavior of those inputs and outputs interacting with that software over the network. So given identical inputs to two versions of the same software, the differences in their actual behavior and the way that they send those network messages should be the changes that were intended to be introduced, the things that you wanted to change in this new version of the software. So comparing the old and the new version allows you to discover what those changes actually are, so that you can catalog what has actually changed between these two releases. And then by filtering out the things that you actually changed, the other things that it can show you are the unknown unknowns, the things that changed in your software that your tests and your existing procedures might not even be checking for, but are some kind of difference that shows up with those sets of inputs. So getting into some more technical depth, the way that we handle this in the network is shown in the inline deployment by the topology on the right here. And we can capture the traffic either inline or passively. But really what happens is the clients that are interacting with the network service, whether that's your QA traffic in earlier in your development process in your CI/CD pipeline, or potentially later at deployment time, it could be your production customers. But whoever that is, they interact with the software and they can get the responses back from, say, version 1, if it's the production users, so that if there's any regression or issues introduced in version 2, it doesn't affect those production users. But Regrade is in a position where it's able to see every request and every response as it goes back and forth between those clients and the version 1 software. So with the upgraded software, Regrade is then able to translate and send over versions of those requests so that the new software gets the exact same requests. It gets the inputs that it would get if the users had logged into that version of the software and gone through the exact same steps. So then we know that we've run both software through the same steps. So when those responses come back from version 2, we can identify exactly what's changed. And this shows us if the performance has changed, if version 2 is slower with certain API calls or faster with certain API calls, or if it just tends to slowly get slower over time. If there's changes that we've made in the bodies that are sent back as the responses to APIs, if we're using some kind of third-party libraries that aren't supposed to have introduced any changes, but maybe we're not doing upgrades because we're concerned that they might be introducing changes that we don't know about. Or even environmental parity. So like moving between cloud environments or changing the configuration of your web application firewall or your load balancer. This allows you to make sure that for your more complicated configurations, everything's actually transferred over correctly and you haven't introduced any unexpected changes when you actually look at that software message by message and see how it responds. And so to make this work, it's kind of the complexity of it is that if you just blindly take a request that's supposed to go to one web application and you send the exact same request to the upgrade version of the web application, there's a lot of things that aren't going to work. One of the most common things that are seen everywhere is session cookies or CSRF tokens that are issued randomly, effectively by the application, and they're never going to match between your version 1 and version 2 environments. And so because of that, they need to be translated appropriately. When a new message comes from the user, it has to reference the correct values of these things that were sent back by the software before. And that can apply to things even down into tags and identifiers that go into the database. So in the diagram here, we're showing things like system IDs or instance IDs or transaction IDs. As you know, software systems have a lot of different identifiers, and sometimes there are cases, or quite often there's cases where they'll correspond between these two environments, but they're not identical. So this allows us, when we see a message from the user, to translate it so that the new version of the software gets messages that are actually meaningful, and the entire session can continue to work correctly instead of just getting back errors that it's not authorized or not properly formed, like you would get back if you were just blindly copying over the entire request. And another complexity that comes up in some of the larger applications is with multiple tier applications. So often in modern deployments, there's applications that talk to another tier of applications behind them, or a persistence layer at the back end. And in these cases, we have the ability to actually test a single piece of software without having to duplicate all the other environments and all the other services that it interacts with on the back end. And so the way we do this is we can set up this environment here where effectively the traffic that, say you had a tier of your application where the input traffic from your clients is coming from HTTP or HTTPS, and then on the back end, you have a persistence layer that is using SQL. So in this case, we can have the traffic come in and it goes directly to the production server. The production server is going to issue its query to the backend database. It's going to get its response back, and then it's going to provide the response back to the user. At the same time, we're also duplicating or translating, I should say, that request to go to the version 2 in the staging environment here. And then it's also going to issue that query to the database. But we don't actually execute the query a second time in that case. So then when we get that second query, we actually send back effectively a cached response of what the production or the version 1 environment got back. So when we send that response back, Then the staging environment gets a response as if its query had executed, but we don't actually duplicate any transactions. So this allows you to not have to duplicate your persistence layer when setting up the environments, but still being able to run the tests side by side. And so that's how we kind of handle the N-tier applications. And so with all of this information, it allows getting to root cause of what's actually going on pretty quickly. So when there is some kind of difference that happens, we can show you exactly what the network traffic is, exactly what request or API call caused that difference, exactly what page of the application is causing some kind of mismatch to come back. So this way, you don't necessarily need to write specific regression tests, because as long as you're exercising the functionality that you want to do regression testing for, any change in that functionality is going to start showing up as a difference. And so in essence, without having to enumerate all of the things you want to check, you're kind of getting those regression tests for free at that point, as long as your API is stable going forward. And then this can save a lot of development time and time in locating and reproducing bugs. So, I mean, often when these things go out into production, you might end up getting a report back from your users where the user ends up saying, hey, I clicked on one of the buttons and I got a spinning wheel and it didn't work. And to a developer, this doesn't necessarily tell you what's going on. With something like this in place, to actually see what the differences are, we can identify, hey, when the user sent this exact API call from the JavaScript that's running in their browser, it caused this spinning wheel because this particular JSON object wasn't formatted correctly. And in fact, here's side by side the proper and improper formatting and a summary of what's changed between them. So it's very helpful for that, and it can also monitor for bugs. So you can catch bugs before release this way, but you can also continue to monitor after release. So then even if you do get a report back from a user that's been affected by this bug, you still also have all this additional information that can show you exactly what was going on with their session. So when hey, this user had a problem at 11:32, you can just check in regrade and say, okay, well, what differences showed up at 11:32 that were associated with that user, and quickly find what changed in their network traffic to give the developer something to hone in on. And then when the developer is looking into this, sometimes just a description of the network traffic, maybe isn't quite enough. You need to dig in more with the actual software, have a debug version and run through the traffic or something. So we have a replay capability. So developers can take the exact traffic, that set of requests that were sent into whatever environment where the bug was seen, and then they can take that same traffic and play it back into the development environment, so that they can then do the same translations with this new live development environment and compare how it's behaving and what its responses are, but also driving that development environment to go through all the same operations in the same order as what actually happened when the bug was seen. And then once the fix is available, that same process can be used to actually validate the fix. The developer can run through that test one more time, and they can see the fix itself show as a difference in the behavior, and that there are no other differences that they've introduced in that code path. You're on mute, Frank.
So we've explained how the technology works. Now it's sort of like, where do I deploy this, right? And so if you're looking at a classic, CI/CD pipeline, where should we go? Well, we can shift left if you want, and have regrade placed early on and be used by your developers to find, bugs and flaws during the development process. We can be used as a, final QA test, if you will, to look at, how is this application, this upgrade going to run it against production traffic, right? And you could run that for a while. It's what we've been talking about, side by side against the existing version that's already working, and you can see how your users are going to interact with this. And then you can also continue to run regrade after you've released your version, right? So you've done the upgrade, but you obviously are, gonna continuously run the prior version underneath in case you have to roll back, right? And we're gonna be able to sit there and monitor things as well. So if something does go wrong post-release, you're going to be able to access the information and the RCA information that Robert just talked to you about, so that if you do have a problem, you can go fix it faster, right? And so really we can be used and should be used anywhere in the CI/CD pipeline. So there's really tremendous value here. Again, in streamlining the SDLC, both pre and post-production, by covering more tests, more testing without risk to users. We can eliminate support calls by over 50%. Being able to track root cause analysis the way we do this is a 50 to 80% savings just in being able to really locate where you need to go to find problems. And we can potentially almost eliminate your API regression testing because we're specifically able to find those regressions before you release, right? And we're going to see side by side how things are going and seeing those regressions ahead of time. So there's a lot of value with what we're doing here. Robert, you want to talk with this? You're on mute.
Sorry, yeah, I was on mute. Yeah, so what we're going to be looking at in the demo is an environment that shows a couple different issues. So Cloudflare is a large company, a CDN, that had a bug in a refactoring, basically, that they did of their code a while back, where they weren't able to see anything that was wrong. They ran through all their tests, everything looked great, and they released a significant bug. And we'll talk a little bit more about that just in a second. And then, yeah, basically they had all their tests passing. They showed no unusual activity. They actually released the code. And once they released the code, there's a small fraction of the requests that were coming in that were sending back the correct response, along with a little bit of leaked out contents of the memory of that server. So they were losing that information basically to the public. They could potentially have secret information. And it was running like that for months, many, many months. And they actually made some changes that expanded the scope of the flaw, that made it happen more often. And then a few days later, someone from Google's Project Zero finally contacted them with a DM on Twitter saying, hey, I found this web page. Every time I load this web page, I noticed there was some extra junk at the end when I scrolled down. And when I started looking at that extra junk, I realized that I was seeing things like the headers of other people's HTTP requests that happen to be on your server. This isn't really good. So once they had that report and they knew the exact page that was loading that had that problem and the exact issue, that the nature of the problem, they were able to fix it by the next day. But by the time they fixed that, it had been actually leaking information out to the public for 149 days. And they had to go around to all the search engines and other places around the web and say, hey, all of the data that you cached from these web pages over the last 150 days, can you please just delete that data? Because it might have some secrets in it that we don't want to have go public. So obviously it's a very bad position to be in. So we'll look at how Regrade could have found and prevented that bug if they had been using Regrade. They could have caught that before release and avoided a lot of that pain. And then the other part of the demo is a quick kind of JSON API comparison, where we're going to be looking at a few API calls and the way that we can identify changes in the way that API is being used. So give me just a second to open up my browser here. Okay. Okay, so this is our product. I'm logging in. I've just generated some traffic to go to our product. So I've sent about 400 requests. And we can see from those requests that there's some differences in HTTP headers that came back. There's some differences in the JSON values. This is that API change that we introduced. And then we can also see the length mismatch error. We actually showed this on the screenshot earlier, and this is what the problem was that Cloudflare had, where they were returning the correct data up to that point, but then the length didn't match because the new software had some extra stuff that got returned at the end. And so if we look at this, we can look at it from, this is basically showing us where in the responses things are different. We can also look at what are the client requests that introduce these changes. So we can see the specific JSON API calls that caused some kind of difference to happen. And we can see each API call had 2 changes that were associated with it. And then there's the API calls from the Cloudflare, where Cloudflare is loading a page and there's one difference. So if we look at the Cloudflare one first, since we were just talking about that, we can see that basically what we have right here in just the summary is the exact page that's being loaded in order to cause the difference. We don't have a content map error, but we do have a length mismatch here. So we know that everything's matching up to here and there's some extra data at the end. And we know exactly how many bytes from each version of the software is getting returned. So this is basically all of the information that was reported in the DM that allowed Cloudflare to find the issue, and track it down and have it fixed by the next day. And if we had done this with a regrade style test, then we would have actually been able to see this difference in behavior of the new version before it ever went live, without any of this extra information ever leaking out across the internet. And they would have been able to fix it the next day. So they never would have actually had a public bug. To dig in on this, we have more information about it too. We can say, exact timestamps, IP addresses, port numbers, things that you might want to use to correlate with other debugging or logging systems. We've got download here that you can actually click here. You can download a packet capture that you can look at in Wireshark or TCP dump. So you can actually see the interaction, the client's requests, and you can see the responses coming back with the extra junk at the end of the HTTP responses. Developers can click here to replay things, so they can basically set up in the environment where their development instance is running, and then they can set up these configurations in order to do that. Oh, sorry, I guess it stopped sharing. So
Yeah.
this,
Go through that again real quick, just so.
Okay, yeah, so I'll go through, sorry about that, I didn't really, yeah, okay, so this is the timestamps right here at the top, and we've got the IPs and port numbers. Down here at the bottom, we've got the packet capture download, where you can see, you can download a PCAP file you can look at, and then the replay. This is where you can see the replay, where the developer can put in where their particular development instance is running, and then they can replay it that way. So that shows basically everything Cloudflare needed in order to track down their issue they could have seen before release. To go into more detail, we can look at these JSON API changes. So this is just kind of a small sample API, but we can see that with these particular API calls, the content length has changed because the JSON response body has changed. In the JSON response body, the value changed of a specific key called hint. So this is JSON pointer syntax. It tells you exactly where in the document the changes are. You can see the value before and after, but in large, complicated JSON documents, that might not be enough to really understand at a glance what's going on. So if you don't have the detailed knowledge of exactly what that key is in the document, you can also look at the full document side by side. So you can see what the old system returned for its JSON document and the new one. And so in context, it's a lot easier to kind of glance at these things and figure out whether this was an intended change or whether this is some kind of bug or regression that's happened there. So that shows a lot of those kinds of changes. And then finally, we can also look at things like the performance profile. So you can see that with these software packages, almost everything came back within 10 milliseconds. We had a couple things that got up over the 10 milliseconds. There's actually just one thing that got in the 10 to 20 millisecond range. But with the new development environment, we've got 50 things that actually came back over 200 milliseconds out of the sample, and nothing came back even over 10 milliseconds from the staging environment. So clearly there's some kind of regression in the performance here. It would be interesting to find out why it is that these API calls are now going so much slower. So the first question then is going to be, what are the API calls? So we can come over here and we can filter down, just say, okay, well, we're interested in just the responses that took over 200 milliseconds to come back. And then we can get the list of which API calls they were and how many times they happened. Because of the nature of my test traffic, each one of these calls only happened exactly one time, but it still shows you which ones it was out of the full sample. So, and then, at the high level, you can keep track of what's a known product issue, the intended changes that we mentioned before in a release, and then what's actually just the unknown issues that are highlighted here that we want to take a look at. So that pretty much summarizes the things we can do and the things to show in this demo.
Thank you, Robert. Thank you, Frank.
Still have some Zoom jujitsu here, I think.
Yeah. So
So-
Frank, I think you wanted to address a few other capabilities, and then we're going to move after that into time for our Q&A. So go ahead.
Right. So again, thank you everybody for attending. Hopefully this has been informative, and you can see how we can find these bugs prior to release, and save you a lot of money. The Cloudflare issue was pretty bad. The Cloud Bleed problem, as it became known later. But what are some of the other use cases? I mean, Robert described several already, but some common everyday things that we need to deal with. Patching risk, for example, right? There's a patch that's been issued. And you want to apply it, but you have something that's working already, and so do you issue this patch and just let it go right out there? It's sort of, and I've heard it called patch and pray, right? Or do I just release it, because you're essentially issuing a new release, right, when you patch something. And so this allows you, regrade would allow you to see the impact of that patch and see if it's going to have any negative impacts. Cloud migrations, Robert talked a little bit about that. If I go from my on-prem environment to a cloud environment, right? Or from one cloud to another, the code may be the same, right? But the cloud environment, may change how it performs. As Robert described a little bit of this, right? And we've seen this with real customers, right? The software may run slower. The cloud providers have their own software that it runs, right? And we actually saw an instance where a customer said, well, we didn't change the software, but something happened. And we showed them that, well, the cloud provider made a change to the software, and that impacted how your software was running. And then finally, refactoring, right? I mean, all of us have some sort of application that is really critical. Maybe it's running our business and a key business for us, and we don't want to touch it, but we know that it's fragile. We know that we don't want to. We know at some point we have to try and deal with that, right? To do something to it. And so where we tend to think, and we've shown you today, of regrade being used to go from one version to the next, sort of in an upgrade scenario. That's sort of the primary use case. With refactoring, you're really sort of maybe looking backwards, right? And so what regrade allows you to do is to say, hey, I've got an existing version. I know it works. I may want to make some changes. Maybe I want to comment some things out. Maybe I want to change this, some of the code, but I don't want to impact what I'm already doing, right? I certainly don't want to, this is a key important app for me. And so regrade allows you to continue running that current app, no impact on customers, no impact on the business, but then any changes you can introduce, you can sort of look at and see, oh yeah, if I commented these lines out, or if I made certain changes, it wouldn't affect my application, or maybe it does, and I can see the impact of that. But again, no impact on users at all. So this is a couple more different ways of thinking about how regrade can be applied. So now we'd like to open it up for questions. I think I saw one or two that were typed in before.
Yep, Frank, why don't we take those first? I'll read it for the group. We have one question that's very basic. We'll cover that one first, and we have time for the others. It's simply, how do I deploy this? How is this implemented? How does it scale?
Yeah, so basically the way that our product deploys, the sensor that looks at all the network messages is a container, so it can easily deploy in any container environment, Kubernetes, Amazon, whatever cloud provider you use. And our user interface similarly deploys in the same way as a container. And then our backend data is stored in a Postgres database, which works very well with all the cloud providers as well. And in terms of scale, the way our product is designed also is so that it can scale horizontally. So you can pretty much use it in any kind of auto scaling environment that has a load balancer in front of it, again, like Kubernetes and a lot of the cloud providers offer. So our product is designed to be able to scale out horizontally to handle large loads.
Thank you. And another question, how do you detect the environment-related bugs, meaning some test cases work in QA and non-prod, but not in production because of the data issues or specific test cases and scenarios?
So yeah, that's a good question. So there's a few different scenarios I can think of. We've seen I'm thinking, when I think of that question, I think some of the cases that we've had users find in their own environments. So we've had places where sometimes the data mismatch issues are really the core of the problem, where, for example, places think that they have an environment where they can set up reliable QA test environments with the same database deployed everywhere. And by running these tests, they actually discover that they're not synchronizing the databases from the same place, or that they aren't actually using the same source data. So sometimes this uncovers actually issues in duplicating or synchronizing the data itself. It can find whatever particular data sets are relevant to an issue, is another helpful way to look at that. So with something like the Cloudflare thing, a lot of requests did not trigger the bug, but by looking at things in a large scale, they were able to figure out which requests and which particular items in their data set effectively did trigger the bug. So by seeing something like that happen in production, that way it allows you to possibly filter down your data set to something that you could reasonably sanitize and copy out into a QA environment. That's really kind of focusing on the data side of things. We've also seen environments where there's differences in things like the web application firewall rules when migrating between different environments. And so that's caused bugs where some requests will succeed and others won't. We've also seen issues with like load balancer configuration that sometimes is in front of complex environments where the load balancer is routing requests to many different services or applications behind the scenes. Maybe one or a couple of those are misconfigured. So this can compare, two different load balancers that are both configured that way to make sure that there aren't any particular addresses that are having problems.
And another, and probably our final question, keep in mind that we can have this as a replay video for your future reference, and if you want to share it. But for our final question, since we're almost up to time, is how do you handle cases where new and nothing to compare?
So when there's nothing to compare to, it's not necessarily going to find a bug in comparing things. It's very helpful with regressions when you can say that the existing software is most likely working correctly. With new software, we're going to say that the difference is that, for example, this request actually gets a response from the new version, and the old version said that's an unknown request. We do have the ability, as we mentioned briefly earlier, to put in what expected changes are. So you can, for the transition between those releases, effectively say this is an expected change that we expect to see, these errors showing up when we're looking at this difference. And then once you've introduced that functionality, you can go back to using the regression capabilities to make sure that for every new release of that functionality, you have something to compare to. And also the other important thing to think about is when you don't have anything to compare to, sometimes you do want to run tests on your new functionality. And a lot of what we described earlier is set up so that that new functionality would be hidden, that effectively your clients or your test traffic is only going to see the old code. We mentioned this briefly, but it's also possible to flip that around. So you can make it so the clients see all of the new functionality coming back, but you still get reports on what's different from the old functionality. So you can run all your QA tests against your new code that way, and then still see the differences and regressions and other things as well.
And Deborah, I think there's one more question on, can we whitelist differences between non-prod and prod so as not to get overloaded? And I think the short answer to that is yes. I know we're going to lose the chat here and the webinar here, but that answer is yes. So for white noise, we can, you can annotate those things out beforehand very easily. And we've developed some techniques to make that easy for you to do.
Very good. And with 1 minute left, we want to wish everyone a great day. We appreciate your participation. Hopefully you learned something new today, a little bit different way to think about solving some age-old problems. So again, thank you for your time, and look forward to hearing from any of you with additional questions. Our contact information is on the screen. Thank you.